74,000 years ago, our planet experienced one of the most powerful natural disasters in its entire history. On the Indonesian island of Sumatra, a volcano erupted with such unimaginable force that it reshaped the landscape, altered the global climate, and may have changed the very course of human evolution. This was the Toba Supervolcano eruption, the largest volcanic explosion in the last 2 million years, and the only supervolcano eruption ever witnessed by our early ancestors. For decades, scientists believed this single event nearly wiped out our species. But, as we'll see, recent discoveries suggest a very different and far more surprising story. If you visit northern Sumatra today, you'll find Lake Toba. It's a stunningly beautiful place. A long blue stretch of water nestled high in the mountains, with a large island rising from its center. It's a popular tourist destination, known for being quiet, scenic, and peaceful. But this lake is not just a lake, it is a scar. Lake Toba fills a massive volcanic crater, a caldera that's nearly 100 kilometers long. It was created when an enormous magma chamber deep beneath the Earth's surface collapsed after emptying itself in a single catastrophic eruption. That island in the middle? It was once part of the crater wall, torn loose and dropped inward during the blast. What happened here wasn't a normal volcanic eruption. It was something far more extreme. So what exactly is a supervolcano? To understand the sheer power of Toba, scientists use a scale called the Volcanic Explosivity Index, or VEI. This scale measures how much material a volcano ejects during an eruption, and each step up the scale represents 10 times more explosive power. A VEI 5 eruption, like Mount St. Helens in 1980, released about 2.79 cubic kilometers of debris. This is equivalent to over 1 million Olympic-sized swimming pools. A VEI 6, like the famous Krakatoa eruption in 1883, was dramatically more destructive and with debris that created global vivid sunsets and reduced global temperatures by around 1.5 degrees Fahrenheit for 5 years. Then you have VEI 7 eruptions, like Mount Tambora in 1815, which was powerful enough to alter the global climate and cause the infamous year without a summer. But VEI 8 eruptions exist on an entirely different level. These events, called supervolcanoes, release over 1,000 cubic kilometers of material, which is over 358 times more than that of Mount St. Helens. They are capable of affecting the entire planet. Toba was one of them, and possibly the most powerful of all. When Toba erupted around 74,000 years ago, the explosion was so immense that it likely vaporized the entire mountain that sat above it. In its place, a vast caldera formed almost instantly. Scorching hot ash clouds, known as pyroclastic flows, raced across Sumatra at hurricane speeds, incinerating everything in their path. A thick blanket of volcanic ash buried the landscape for thousands of kilometers around. But the impact didn't stop there. Huge volumes of debris were blasted high into the atmosphere, spreading across Asia and far, far beyond. Geologists have found ash from the Toba eruption in India more than 5,000 kilometers away. It's been found all across Southeast Asia and even in East Africa, over 7,000 kilometers from the eruption site. This wasn't a regional disaster, it was a planetary event. Volcanic eruptions don't just destroy landscapes, they can change the climate. When a volcano erupts, it releases gases like sulfur dioxide into the atmosphere. This gas can form tiny particles called aerosols that reflect sunlight back into space, cooling the planet. We've seen this happen with smaller eruptions. Tambora's VEI 7 eruption in 1815 caused global cooling for over a year. But Toba was vastly larger. Early climate models painted a terrifying picture. They suggested that the Toba eruption may have caused global temperatures to plummet by as much as 10 to 15 degrees Celsius. This could have triggered a volcanic winter that lasted not for a year, but for centuries. Forests may have died off across large parts of Asia. Rainfall patterns could have collapsed. Entire ecosystems would have struggled to survive. And then there was humanity. In the 1990s, geneticists studying human DNA noticed something strange. Modern humans show remarkably low genetic diversity, far lower than you'd expect for a species that has spread across multiple continents. This pattern suggested that sometime in our distant past, the human population may have crashed to extremely low numbers, an event known as a population bottleneck. When scientists compared the timing, The genetic bottleneck appeared to line up almost perfectly with the Toba eruption. The conclusion was chilling. Some researchers propose that Toba's eruption nearly wiped humanity off the face of the Earth, reducing our global population to as few as a few thousand individuals, maybe even less. According to this theory, every single human alive today would be descended from this tiny, hardy group of survivors. For years, this Toba catastrophe theory dominated documentaries, textbooks, and popular science. But science rarely stands still, and the story was about to get a lot more complicated. As archaeologists excavated more ancient sites, cracks began to appear in the catastrophe theory. In southern Africa, researchers made a breakthrough. They found layers of microscopic volcanic glass from Toba embedded in ancient coastal sediments. These layers acted like a time marker, allowing them to see exactly what human life was like right before and right after the eruption. What they found was completely unexpected. Instead of a collapse in human activity, there was evidence of continuity, and in some cases, even growth. They found more stone tools, not fewer. They found more food remains. They even found early signs of symbolic behavior and art. Similar patterns started appearing in India, where archaeologists uncovered ancient human settlements directly beneath thick layers of Toba ash. If humanity had truly gone to the brink of extinction, this evidence simply shouldn't exist. Another key discovery came from analyzing the chemistry of Toba's magma itself. It turns out that not all volcanoes release the same amount of climate-cooling sulfur. Chemical analysis of Toba's ash revealed that its magma may not have been especially rich in sulfur dioxide. This means that its eruption may not have caused the long-lasting, devastating volcanic winter that was once believed. The new thinking is that while the eruption was undoubtedly catastrophic on a local and regional scale, its global climate effects may have been shorter and less severe than we first thought. Instead of nearly wiping out humanity, Toba may have been a major challenge that our early ancestors survived and adapted to. This is what makes Toba so unique. Unlike other supervolcanoes in Earth's deep past, humans were there to witness it. Early Homo sapiens lived across Asia at the time, and other human relatives. Like Homo floresiensis, the so-called hobbits of Indonesia lived nearby. It's almost certain that some groups perished in the blast and the immediate aftermath. But others likely survived thanks to their location, favorable wind patterns, or access to coastal resources that were less affected by the ashfall. Toba may not have destroyed humanity, but it almost certainly reshaped our world. It would have altered migration routes, changed ecosystems, and forced cultures across Southeast Asia to adapt or die. Uncovering this incredible story was a masterpiece of scientific detective work that spanned decades. It began with ice cores drilled deep into the Greenland ice sheet, which revealed massive spikes in sulfuric acid dating to around 75,000 years ago, a clear sign of a huge volcanic eruption somewhere on Earth. At the same time, sediment cores drilled from the ocean floor showed a sudden global cooling event at the exact same time. Then, geologists started finding volcanic ash samples from all over Asia that shared the same unique chemical fingerprint and the same age. That fingerprint led scientists back to one and only one possible source: the massive, quiet lake in Sumatra. Piece by piece, the incredible story of Toba came together. All of this raises an unsettling question. Could it happen again? Toba is located on the Pacific Ring of Fire, one of the most geologically active regions on the planet. A major fault line runs directly beneath the volcano, and we know that magma still exists deep below the surface. While another supereruption is not considered likely anytime soon, it is not impossible. And if it did happen, the consequences for our modern, interconnected world would be severe. Today, tens of millions of people live in Sumatra and nearby regions. Major cities like Medan, Kuala Lumpur, and Singapore lie within the potential range of heavy ashfall. Even without a full-scale supereruption, a large eruption from Toba could cause mass displacement, infrastructure collapse, and regional food and water shortages, sending shockwaves through the global economy. Can we do anything to stop a supervolcano? In recent years, scientists have started exploring some bold, even radical ideas. One proposal suggests we could slowly cool a magma chamber by drilling deep wells and extracting its heat over many decades, like a geothermal power plant. In theory, this could reduce the pressure building up inside and prevent a catastrophic eruption. For now, however, such ideas remain highly experimental. Humanity's best defense against these forces of nature is monitoring, preparation, and a deep understanding of the risks. The story of the Toba super eruption reminds us of something profound. Our planet is powerful, our history is fragile, and our survival has never been guaranteed. 74,000 years ago, our ancestors faced one of the greatest natural disasters Earth has ever produced, and they survived. Whether it was through resilience, adaptability, or just sheer luck, we endured. And today, the quiet, peaceful waters of Lake Toba remain as a silent reminder of just how close the world once came to being a very different place. If you enjoyed this journey into our planet's explosive past, be sure to subscribe for more stories. Thanks for watching.